Hi, I'm Cal Rubin, an applications engineer specializing in embedded technology here at Altera. Did you know that a 100% MIPS-compatible soft processor called MP32 is now available exclusively for Altera FPGA? What's more, this is also the industry's first soft processor that runs the VxWorks operating system. In this video, we'll cover the 5 reasons why you should use the MIPS-compatible MP32 processor in your next programmable logic design. As we go through the 5 reasons, we'll demonstrate how you can develop software for the MP32 using a Stratix 3 FPGA development kit running the processor. Our setup is fairly simple. This EJTAG daughter board is attached to the development kit and provides EJTAG as well as RS-232 connectivity. The kit is connected to the laptop, which is running the VxWorks development environment called Workbench. Workbench is Wind River's Eclipse-based development toolset. I would like to point out that since MP32 is a soft processor, it can run on any Altera FPGA development kit, not just the one we're showing here. Now, let's start with reason number 5, faster time to market with IP reuse. The MP32 processor inherits an expansive portfolio of IP cores for embedded processing, protocols, memory control, and applications including video, DSP, and networking. You really get to take advantage of the entire MIPS ecosystem. Wind River offers device drivers for many of these peripherals. And not only will you be able to reuse a lot of third-party IP, but also your own. That'll save you time and effort in developing your custom applications. Another way to save time and effort is to automate your system integration, which brings us to reason number 4. You'll save time and effort in system integration with our common FPGA design flow, Qsys. The Qsys system integration tool is available in Quartus 2 design software. Qsys automatically generates interconnect logic to connect IP functions and subsystems. Let's go to our laptop and development kit, and we can see how easy it is to stitch together a system using Qsys. We'll go ahead and launch Qsys, which gives us a blank canvas for building our systems. There are 3 main windows in Qsys. The window to the left here is for the component library. From here, we'll pick from a list of components to add to our system. The new component item launches a GUI which allows us to add our own custom components to the list. The message window is the bottom window. It will show any warnings or errors detected in the system as we create it. Finally, the main window is where the system is built and the components are interconnected. So let's get started. First, we'll add the MP32 processor from the pick list on the left, and we'll configure it. Here's the configuration dialog box for the MP32. As you can see, we can choose various settings, such as cache size, the endiness of the core, and our reset location. Because we haven't defined any memories in the system, we can't specify the reset location just yet. So let's go ahead and add a DDR2 memory controller. I'll choose the memory that's on the board and set up the clock frequencies. Now let's go ahead and connect our instruction and data master to the memory. The console output for VxWorks uses an RS-232 UART, so let's add that. We can also add a PIO to drive the LEDs on the board. We can continue to add components and peripherals in this manner until we've got all that we need for our system. When we're ready to generate this system, we'll just click Generate to create the Verilog or VHDL interconnect for our system. Here's a system we built earlier on, so you can see what a finished system may look like. This system includes DDR, flash, PIO, UART, and an Ethernet subsystem. As you can see here, the colored lines help show how all of our components are interconnected. In this design, we have used one MP32 processor. But because the MP32 is royalty-free in FPGAs, you can easily add multiple soft processors. This point leads nicely to reason 3 for using the MP32 processor: increased performance by using multiple MP32 processors. Because MP32 is a soft-core processor, you'll use the logic and the memory resources of your FPGA. This means that you can use as many MP32 processors as you can fit on your FPGA, and each processor can perform a dedicated function. For example, you could have a main processor running the operating system and the application layer software, while you have another processor just handling the I/O of the user interface. Your third and fourth processors can handle the Ethernet traffic and image processing. By using multiple processors, you can get a significant performance increase. Now, the MP32 processor is performance optimized for all our FPGAs and hard copy ASICs, including previous generation and future devices. Since the MP32 processor utilizes as little as 1% of an average FPGA, you can see that you've got a lot of processing power at your disposal. Now that we've completed our hardware system, we can start writing some code for our processor. This brings us to reason number 2. The MP32 inherits the MIPS ecosystem of software, tools, and operating systems. Since the MP32 processor is 100% compatible with the MIPS 2.0 architecture, you can reuse software that you've already written for your MIPS processor and also take advantage of all of the institutional knowledge that goes with it. Oh, and you can use your favorite development tools too. Let's take a look at how to build a software application for your MP32 processor. This is where the Wind River Workbench tool comes into play. Using Workbench, Wind River has developed a board support package for the MP32 and our Stratix 3 development kit. In Workbench, we'll create a new project. Select Wind River VxWorks 6.8, Bootloader BSP project, and give the project a name. Finally, we'll select the Alt MP32 Stratix 3 BSP. MP32 is fully supported by the Wind River tools. Not only can you use your favorite development tools, but you can also use your favorite operating systems. The largest installed base of embedded software in the world has already been written for the VxWorks operating system. This leads us to the number one reason for using the MP32 processor. MP32 is the first and only soft processor that supports the VxWorks operating system. As you probably know, VxWorks comes with a lot of useful software and middleware that you'll be able to use and reuse in your application. Once we've completed the application based on the VxWorks operating system, we get an image file that can be programmed into the flash on our target board. When the processor powers up, it will start the VxWorks system boot, which will grab the VxWorks software image from an FTP server. We can confirm this by monitoring the target through the console, which is on our laptop. We've already powered up the board, so we'll hit the reset button on our board. At our terminal here, we can see the boot screen. And here you can see the VxWorks banner coming up, which means that VxWorks has successfully booted up across our Ethernet cable. We hope today's demo gave you a clear understanding of the 5 reasons why you should use the MP32 processor in your next FPGA design. In summary, reason 5, get faster time to market with IP reuse. Reason number 4, save time and effort in system integration with Qsys. Reason number 3, increase performance using multiple MP32 processors. Reason number 2, accelerate software development by reusing your favorite MIPS software tools. And finally, reason number 1, take advantage of using the VxWorks operating system, since MP32 is the first and only soft processor to support it.